So let's continue with our Feb March 18 paper, the next 10 MCQs. All right, so question 11, the reaction between sulfur dioxide and oxygen is reversible, and they've asked the conditions of pressure and temperature that favor the reverse reaction. Now, know that an increase in pressure favors the side that has less number of gaseous moles. In this case, well, all three substances are gases. So on the right hand side, you have 3 moles because 2 plus 1. On the left, you have 2. So in this case, if you increase pressure, it will go to the right. But you want the reverse reaction, which is why you have to decrease pressure and it'll go hence towards the left. It'll go towards the side with more number of gaseous moles. Okay. Now for temperature, now there's a proper logic and a way to explain this. I am too bored to go through it. So just remember the jugaad, Hend, Lex. High temperature favors endothermic side, low temperature favors exothermic side. Now the forward reaction is exo, so it should go without saying that the backward reaction would be endo, just the opposite, right? And you want the backward reaction. As seen by Hend, Lex, high temperature favors endothermic side. Endothermic side is the backward reaction, hence you want higher temperature. C. 12. Which statement about the effect of a catalyst on a reversible reaction is correct? A catalyst reduces activation energy. The equilibrium mixture, the composition remains the same because it doesn't change equilibrium position. That is something that you should know about a catalyst. It has no effect on the equilibrium position. For stuff like that, you have temperature, pressure.
It doesn't change the yield. It only changes the rate. And it changes it for the backward and forward reaction by the same magnitude.
Basically. All right. So the rate of backward reaction stays the same. No, it increases. Both the rates increase. The value of the equilibrium constant changes. No, it again stays the same because the equilibrium position is the same. And on the side note, you should know only the temperature. Only the temperature can change the value of the equilibrium constant. Not even stuff like pressure and stuff of that sort. Uski bahut lambi logic hai, but just remember, aapki Kc ki value is only changed by temperature. Anyhow, but you don't need this. You don't need to know that. You don't need to know that much for this MCQ, anyways. So let's just proceed. Which oxide is insoluble in aqueous NaOH? Now, what you should know is that acidic oxides are so acidic substances are soluble in alkaline substances, obviously, and alkaline substances are very soluble, readily soluble in acidic substances because they react so very easily they can dissolve and become soluble. SO2 is acidic; it would easily dissolve in an alkali like NaOH. So would phosphorus, so would aluminum. These are all acidic oxides. However, MgO is definitely basic, so it would not dissolve in something that is also basic like NaOH, which is why you can say that that is insoluble. So we go on with 14. So you have X, Y, and Z are 3 elements in the third period. X react with chlorine to give a liquid product. Y reacts with chlorine to give a solid product that dissolves in water to give a solution of pH 7. Z reacts with chlorine to give a solid product that dissolves in water to give a solution of pH 6. Which elements are good conductors of electricity? So what do you think about this, Hamza?
One thing's fairly obvious when it says Y reacts with chlorine to give a solid product. So I assume they're talking about NaCl in this case, or something that's in the first group of the periodic table.
Yeah, because only that would dissolve in water to give pH 7. So obviously, sodium would be a good conductor. And NaCl and then we have Z. So if you have a pH of a pH 6, that is very slightly acidic, not very different to what MgCl2 forms that has around 6.5 pH. So like something of that sort. So that also, and since it's a solid product, it kind of indicates to you that an ionic compound would be formed when this element reacts with, what do you say, chlorine. However, in the case of in the case of X, it's forming a liquid product, indicating that this is not ionic. It's probably covalent.
Covalent or
Because if it's covalent, then it would probably have like stuff like van der Waals forces or permanent dipoles between the molecules, which aren't that strong, which is why it's liquid. Ionic bonds are pretty strong, so that obviously they exist as your ionic lattice, and that's going to be solid. So if it's covalent, normally if it's bonding covalently, covalent character. I mean, it would indicate that it would not be a very good conductor of electricity because ions can conduct, but a covalent simple molecular molecule might not conduct as well as much. So are we?
but SN, no, it says which elements are good conductors of electricity. So if X is forming a covalent bond, I have reason to assume it is aluminum, right? Because it's in the third period and it is the one which forms a covalent bond, not magnesium, not sodium. And it says these are three elements in the third period. They're not consecutive. Okay, that's another thing. So yeah, I didn't see that.
All right, all right. So, and even with aluminum, it does form a covalent bond, but it still has some ionic character. It has both, right? It has a covalent character, it has some ionic character. So I'm not even sure if
ionic.
Yeah, so if it's a liquid product, I'd mainly look more towards either phosphorus or I think sulfur. Like,
yeah, makes sense.
So are we justified with concluding with B, saying that only Y and Z conduct?
Yeah, definitely.
Yeah, because these are your metals. So obviously they've asked for elements, right? So if Y and Z were like sodium or magnesium or some metal similar to that, metals conduct even in elements because they have delocalized electrons. If you have X, which is either, let's say phosphorus, for example, that won't conduct as an element because it won't have delocalized electrons. So to put it very simply, anyhow, 15. A solution contains both Mg2 positive and Sr2 positive in the same concentration. The solution is divided into two equal portions. NaOH is added dropwise to one portion, and dilute sulfuric acid is added dropwise to the other portion. Which row is correct? White, so precipitate seen first when NaOH is added. Now, what you should know is that as you go down group 2, the reactivity
increases.
And Hamza, could you explain why?
Yeah, because as you go down the group, the distance of the outermost electron from the center of the nucleus increases. So the force of attraction on it also decreases. Therefore, it becomes easier to lose an electron and form bonds. So the reactivity increases. It becomes easier to form bonds.
All right. And what's basically happening here, we could say, is there like a displacement reaction with where you're displacing sodium in a way, one could say?
Yeah, sort of like the qualitative analysis notes you have in your practicals, right? So you're forming precipitates with sodium hydroxide solution.
And so which precipitate, and wait, so just a second. But down the group, so down group 2, the solubility of
hydroxides
increases. So in fact, we could say that strontium hydroxide might be more soluble than magnesium hydroxide, which means that we're more likely to see magnesium hydroxide appear first, right? It easily form a precipitate, but with strontium hydroxide, you can add hydroxide, it'll still be soluble, and after a particular amount, maybe it will form a little precipitate.
Yeah. That too.
So because solubility of hydroxides increases down the group, the more insoluble substance which will form the precipitate the fastest, the most easily. So it would be magnesium hydroxide. And so in fact, we didn't have to link reactivity with this. We just had to link solubility. Yeah.
But SN, it says that you're adding sodium hydroxide dropwise, not adding the ion dropwise, aqueous ion. So if you're adding sodium hydroxide dropwise, then you're not getting solubility immediately. You're just getting, if you're getting precipitates, they're not going to dissolve because there's such a less quantity of sodium hydroxide initially.
Yes, but but like I would say it's either drop wise. I mean, until you get a precipitate, right? So you would eventually get a precipitate,
Yeah,
and the idea here is
yeah, yeah, yeah.
strontium hydroxide might still form a precipitate sometime down the line if you add enough of NaOH, maybe. But as you're
Hmm.
adding two drops, strontium hydroxide is just going to remain soluble. However, magnesium hydroxide, well, that would precipitate, and that would precipitate faster because it would just take a little. It would take much less drops for magnesium hydroxide to precipitate because it's just more insoluble. Uh, and the other thing you need
Yeah,
to know is as you go down the group, the solubility of sulfates, this decreases.
decreases.
So here your strontium sulfate is more like it will form faster because it is more insoluble. In fact, magnesium sulfate is more or less soluble. It's in fact almost you can say soluble. So that precipitate probably wouldn't be seen anyways. Um, and anyways, this solubility character is very interesting. You learn the logic behind this in A2. But for now, just remember down the group, solubility of hydroxides increases, solubility of sulfates decreases, and that's how you have to solve this particular question. Anyhow, the volatility of group 17 elements, so group 7 basically, chlorine, bromine, iodine, decreases down the group, which means that down the group they vaporize less easily. That's like kind of the idea behind volatility, how easily you vaporize, one could say. Now, what is responsible for this? Now you have to look at well, volatility again would kind of like similar to your boiling point, or your kind of links to your
Yeah,
intermolecular forces. So intermolecular forces does not link to bond length, does not link to bond strength. Now intermolecular forces could be affected by the electronegativity, it could be affected by the number of electrons. However, the reason I would conclude with D rather than electronegativity is because if you think about this, you have Cl2, Br2, uh, I2. So irrespective of how electronegative the halogen is, the electronegativities just get cancelled out. Overall, these are still non-polar because there are two, right?
non-polar.
Yeah. So if it's Cl, if it's Cl, this might be slightly this might be, these both might be electronegative, but they just cancel out because they're kind of pulling each other. So that overall effect is zero. Anyhow, so now they don't have permanent dipoles. They in fact just have van der Waals forces, and van der Waals just depend on number of electrons. So as down the group, number of electrons increases, so your boiling point kind of goes up. It becomes more difficult for you to vaporize that easy vaporize. So that's kind of like the idea. Bromine is extracted from seawater. In the final stages of the process, two redox reactions take place. Which row is correct? Well, just off the top of my head, even if I don't look at these two reactions, one should know that down group 7, oxidizing power reduces. So chlorine will be a stronger oxidizing agent than bromine, and I believe you studied this anyways. So just basis on the basis of that, you can cancel out A and D, just on your knowledge basis, because you know chlorine has to be a stronger oxidizing agent than bromine anyways. But let's look at the question and let's look at the two redox reactions and try to figure out stuff from there. And that's basically what the second equation is telling you, how chlorine very easily displaces bromine. Hence it, what does it do to bromine? It in a way oxidizes bromine from Br negative to Br0. Hence it clearly shows that chlorine is has a greater oxidizing power than bromine. That is what reaction 2 is telling you. But what is reaction 1 telling you? So what happens in reaction 1 is how bromine bromine was 0, it went to negative, which means that bromine itself got reduced. It went from 0 to -1. So that is a decrease in oxidation state. It got reduced, which means it oxidized SO2. So which means here bromine is the oxidizing agent. SO2 wasn't a stronger oxidizing agent than bromine. It was bromine because bromine managed to oxidize SO2 and itself obviously got reduced. So that means bromine is going to be stronger oxidizing agent than SO2. So you have to pick between B and C. You would pick B because bromine by reaction 1 is a stronger oxidizing agent than SO2. 18. When burnt, sulfur forms a gaseous product X, which can be oxidized to produce a gas Y. So this is kind of obvious. When burnt, sulfur forms SO2. And since it can be oxidized to produce gas Y, that is SO3, because like what else would it form? Obviously, when burned, it would react with oxygen, so it will form one of the two sulfur oxides. The reason I know it is SO2, even if I don't remember it, is because only SO2 can be further oxidized to SO3. Gas Y reacts with water to produce a product Z, that is sulfuric acid. I believe you studied this in your contact process, was it? Something of that sort. So which
Yeah.
row correctly shows the oxidation states of sulfur in X, Y, and Z? So this is, in X, it is +4. Just link it to how many oxygens there are. Oxygen is always going to be in 2 negatives. So 2 oxygens is -4. So sulfur has to be +4 to balance it out. Here is going to be +6. Here will also be +6 because if you think about it, hydrogen is going to be plus 1. It's 2. There are 2 hydrogens, so +2. Oxygen is -2. Sorry, -2 for 1 oxygen. There are 4 oxygens, so that makes it -8. And only if sulfur is +6 does the entire thing equate to 0, which it needs to. So that is +4, +6, and +6. +4, +6, +6. You're good with D. One molecule of ammonia reacts with one molecule of ethyl methanoate to produce one molecule of methanamide and one other molecule X. One molecule of methanamide decomposes on heating strongly to produce one molecule of ammonia and one other molecule Y. What could be the identities of X and Y? So let's look here. So there's ammonia coming, and if we draw the structure of this will be something like, if you draw the structure of ethyl methanoate, that would be something like this, right? Now, as it reacts, what happens is, so what basically is happening, it's forming an amide. This is an amide. So what's first going to happen is the ester bond is going to break, and then instead of this particular substance being there, you would get ammonia. So that is NH2. NH2 comes here. So you get this amide. Obviously, ammonia was NH3, so you have to wonder where did one H go? And you would be justified in saying that one H just helped this alcohol complete itself. So the ester bond broke. The one hydrogen from ammonia came and helped this alcohol complete itself, and the rest of the ammonia came here and formed an amide, because you can form an amide with a carboxylic acid and ammonia. Anyhow, so you have this, which would be, there are 2 carbons, so this is ethanol. So you can cross out A and B just on those grounds. Now, one molecule of methanamide decomposes on heating strongly to produce one molecule of ammonia and one other molecule Y. So if I can just rub some of the stuff that I wrote to clear up some space. Now, this, we know that it's going to break from somewhere around here. And why do we know that? Because, well, NH3 has to be formed, so this has to go away. Now, what does this do? This should, well, the options we have is either hydrogen cyanide or carbon monoxide. Hydrogen cyanide, I don't think it would be cyanide, because the hydrogen cyanide would be HCN, and we wouldn't have N. The only nitrogen we did have that went away in ammonia. So it clearly should be C, but let's try to explain why it should be C.
SN, the molecule has 3 H overall and 1 nitrogen, and it says it just forms one molecule of ammonia and one molecule Y. To form ammonia, the NH2 would be removed, but it would need one more H. So the H before the C automatically goes away over there, because it's just this molecule that's being decomposed, which leaves you with only CO.
Yeah, so Hamza's useful. Okay, yeah, so the blue arrows that I've drawn, that stuff goes to form NH3, and that leaves you with CO, which is carbon monoxide. So that gives you C. Which types of stereoisomerism are shown by, oh, let me rub what I've written over this, 2,4-dimethyl hex 2-ene. So let's draw this. It's hexene, so that's 6, I believe. 2, 3, 4,
Yep.
1, 2, 3, 4, 5, 6. Now, if you start counting from, let's say, your left-hand side, you hex 2-ene. So this is 1, 2. So this would be your double bond would attach here. And at the same time, you need 2,4-dimethyl. So what I've done is I've counted from here. So this is 1, 2, 3, 4, 5, 6. Just to clarify. Anyhow, so methyl groups you're going to attach on 2 and 4. And you want to figure out what types of isomerism they show. Now, one should know that I don't think this can go cis trans, because for cis trans you need two different groups attached to both double bonded carbons. So it works in this particular case in the carbon number 3 because it has hydrogen and the entire carbon chain. That's fine. But in carbon number 2, it's just attached to two methyl groups. If you think about it, if you just look here, they're just both methyl groups. So it can't. The double bonded carbon has to be attached to two different groups. So in this particular case, you cannot undergo cis trans, so you can cross out A and B. Hamza, do you agree with the fact that we can't do cis trans here?
Yeah.
Okay.
Yep.
So
they're both the same molecules.
Okay. So for optical, if we draw, so this is this is CH2. I was just adding the carbon, the hydrogens. Sorry. So for optical, you need a chiral. So remember, your double bonded carbons cannot be chiral because you need to be bonded with 4 different groups. However, I think this particular carbon can be, because it has this as a different group, a hydrogen. It has a methyl. It has, well, an ethyl chain on one side, and it has a whole lot of mess on the other side. So carbon number 4 can be optical. So I feel you can conclude with D, right?
Yeah.
So let's quickly check our answers.
Okay.
All right, so all our answers were fine so far. So these 10 MCQs were correct as well. And we'll see you with the next 10 in the next video.